going to discuss about the RDD operations. So there are two kinds of operations we usually have in RDDs. One is called transformation and other is called action. So let's start with the transformation. RDD is a data structure, or it is a collection in a distributed manner, which is the basic elements of the Spark core. So now when we have a RDD and we apply another transformation, like we have an RDD and we apply a transformation function, that means it produces a new RDD. Every time you apply a transformation, it produces a new RDD from the existing RDD. And whenever we perform some manipulations on the particular RDD, and then just to produce new RDD, right? Now while performing this transformation, input RDD, which is the existing RDD, the input RDD doesn't change. Why? Because these RDDs are immutable. Now whenever we apply different transformation, then what happens, like it actually builds the RDD lineage. RDD lineage is like a DAG. So just lineage starts from the parent RDD and then n number of transformation applies to final RDD. That means in this lineage, it's a DAG, you can say, or different like RDD graphs or operator graph, or we can say operator dependency graph generated, and then it keep track of all the operations in that. Now this transformation is actually your logical execution plan. That means you create an RDD, then you apply different transformation. That logical execution plans are there, and which are there in the directed acyclic graph. As we discussed in the last session, that these transformations are lazy in nature. That means they execute when call an action onto that. The basic transformation basic transformation are like map and filters. Now the transformed RDD may be recomputed. So whenever we transform the RDD, that means this transformed new RDD may be recomputed whenever each time runs an action. We call an action again and again. Then each time this RDD is recomputed. I'm just writing each time run an action. This RDD is recomputed every time, but we can avoid this by using the persistent RDD, and we are going to discuss in detail about the persistent RDD. Now when we do the transformation on a particular RDD, this transformed RDD is completely different from the parent RDD, because we applied a transformation. This transformation can be any map, and we are going to see that. So this transformed RDD is different from the parent RDD, and it allows you to build the logical transformation plan. Now these RDDs are of, like you can see, we can also distinguish this RDD in terms of narrow RDD and the wide transformation. Sorry. Now this transformation can also be defined in terms of narrow transformation and wide transformation. So let's say we have a narrow transformation. In the narrow transformation, the important thing is that all the elements that are required to compute the record in a single partition, they live in a single partition. What I mean to say that, yes, I'll show you this demo. Let's say you have one partition. This is a different partition. I'm just drawing in a different way. Okay, the transformation, that means all the elements that are required to compute the records in the single partitions. That means this partition is required to compute that all the data lives in a single partition. Similarly, in this also all the data lives in single partition. So what I'm trying to say, this is very important to understand, that all elements that are required to compute the records in, you can say, single partition. Here I'm talking about this one. That means this lives in single partition. So whatever the data you are computing for a single partition, the input data is also lives in a single partition. So this is your narrow transformation. Now on the other hand, I can say that wide transformation is something like, let's say you have this data is in this partition. Am I drawing in a different way so that these you can understand this is a different partition. Now in this type of transformation, all the elements that are required to compute lives in a records in a single partition lives in multiple partition, right? So it lives in many partition or multiple partitions of the parent RDD. So now we can see this is our data which need to compute in a single partition, may contain the data from this part, may contain data from this part, and may contain data from this part. So this means the data which we are going to compute in a single partition may lives in many partitions. Definition changes over here. So I'll just write this definition. All elements that are required to compute the records in single partition that lives in many or multiple partitions of parent RDD. Okay, so this is about the wide RDDs. That is about the wide transformation. And if we see the example of narrow transformation, the examples are, if you see the examples of narrow transformation, examples are like map or even flat map, and we have a map partition functions and some other function like filters, sample, union. These are the functions which are part of the narrow transformation. And similarly, on the other side, if we see some examples of the wide transformations are like intersection. We need many partition as in a parent RDD, or even distinct. Few very interesting and important functions like actions like reduce by key, group by key, and we are going to discuss these different actions and transformations, joins, even Cartesian, or you can say repartitions, coalesce. So we are going to see this different transformation later on. So out of these transformation, let's uh, understand few of the transformations. Now let's see few of the examples of the transformation. One of the example is like a distinct. The distinct is a transformation. What the distinct do is it removes the duplicates from the RDD. Okay, and then how we can use that? So let's say our RDD is rewards, then we need to use called distinct function, distinct transformation, and then I'm applying some count so that I can count how many distincts are there. Similarly, let's see some other one, filter. Filter transformation is, this transformation is like SQL, you can say like where clause. So the where clause which you use in SQL command, it is something like that, and this returns the boolean variable true or false. And we can use this, like word is again an RDD, and I can call that uh, words is an RDD. Then we can call like a map function over here, or sorry, the word is an RDD, and then we can call filter, and then we can call, like, let's say in Python we are calling lambda. This is x, and then I can call x dot starts with the word, any word like s or something like that. Then this will filter the based on this one. So it will give you either this value, this element of an RDD is either starting with s or not. Then it will give you the boolean value. Okay, and this is a very very simple function. Similarly, you can also we can also define that map function, map transformation. The map transformation is actually applied to this is applied to each element of an RDD, each element of an RDD. And You can take one element as an input. You can take one element can take one element as input, and then it process it. Okay, and then it will return the result one element. So this is the how the map transformation being processed. So let's take an example. Let's say uh, we have an RDD called words, and then I'm applying a transformation called map, and then I'm using a lambda. I'm using x plus 5. That means x will contain the elements of the RDDs one by one. The one by one element of word RDD, and then it apply the process like x plus 5, and then it will result one element RDD, and that will be stored into the result will be stored into the new RDD. This is in Python. So this is in your Python, and we can also write in Scala. Similar element like RDD1 is equal to words dot map, and then we have to call x. This symbol is an anonymous function, and x plus 5. Then this is in the Scala. Now, very interesting function is Flatmap. This Flatmap function is something similar to your map function, but it allow you to return 0 or 1, or you can say more elements. Now in this function, the developers can you can say define own logic, right? It actually transform an RDD of like length n into another RDD of length m. Okay, so now it changes the length of the m. Just to understand, the example is like, let's say in a file you have some word like some words are there like a, b, c, d, and e are there, right? And in another line, let's say you have some f, g, h, i, and then in line k, l, m, something like this in the file. Let's say this is in the file, and you apply a transformation like RDD is equal to, let's say this is a part of the data. So this is a data RDD. So you call it data dot flat, m is capital, flat map, and then you apply let's say you apply the lambda function, and I'm writing in Python, and then you call x dot split. If you call x dot split, what will happen? This data is one by one coming into x, and this x dot split means it will split based on the space. This is a space, so this is a space, and this is split based on that. So now what this flat map will do, it will return you the a, b, c, d in a different different rows of the file. Similarly f and g. So now the output will be like based on the split, because this is my own logic, on which logic I'm splitting or I'm doing anything else. So now this a will become the first row, then second row, and this each element will be split based on this, and it will create a number of rows into that. Similarly, we can also define this in Scala like RDD1 data dot flat map, and then we have, let's say, line L dot split, right? So in this way, from data to we are splitting into RDD1. So this is about the transformation. Now let's discuss about the action. The second part is of the types of transformation is actions. Now transformations are lazy in nature, and then they get executed, because transformation are the logical plans and they get executed when we trigger an action. That means the action are actually a triggers of computation, or you can say actions are the action triggers the computation and which returns the result. Okay, with the transformation we don't get any results, and it saves a lot of time and this RDD evaluation is being used just to optimize the processing. Now this actions gives non-RDD value. That means it is not returning a RDD just like a transformation. It will give you the final result. Okay, it will give you the final results, and it will give the value of the action is like is to store to driver program where this code has been called, or you can say some external storage system. So once the action has been called, this value of this action either you can call to or store to, return to or store or return to a driver program, or you can store into some external storage device. So you can say this action is a way of sending data from executor to your driver. So this is another way of, you can say in that way also. The well-known examples of functions are like few of you have done already. The like count function is there as an action, collect, take, n, or like first. We have discussed few of them, and then we are going to discuss in the next coming sessions about more important, very important actions like count by value, or you can say we have a reduce action, or even fold is there, or aggregate, and we have for each, or you can say count by key, or save as a text file. So we are going to discuss this in detail. So let me tell you only one function called count by value. So this is the action. This returns, you can say this returns count of each unique value in the RDD. Okay, so return will be like value, what is the value, and then the count of the value. This is a pair RDD, it will return you. And this function or action, you can say, is suitable for small number of values. That means it returns value to the driver program. That is why we need to have a small number of data set just to use this one. Okay, so that's all with this RDD operation, which is transformation action. Thank you very much for watching this video. Thank you very much. Bye.